Hey there, so next we're moving into chapter 8 where we study confidence intervals. It's a very interesting topic, so I'm excited to get started. All right, starting in section 8.1, confidence intervals for a single population mean with sigma known. Okay, so let's talk about what we mean by confidence intervals. So inferential statistics is where we use sample data to make generalizations about an unknown population. Okay, that's what it's all about. We want to use our sample to see if we can make generalizations. But we realize that the point estimate is most likely not the exact value of the population parameter, but close to it. So we want to start talking about how confident are we that we're getting really, really close to that actual population parameter when we're just looking at our statistic. Okay, note that the sample mean X bar is the point estimate for the population mean mu, and the sample standard deviation S is the point estimate for the population standard deviation sigma. So the idea going into this is if you get a sample mean, it's probably pretty close to the population mean, but how close and how confident are you that it's within a certain margin of error, right? That's what we're interested in. So a confidence interval is an estimate that provides a range of reasonable values in which we expect the population parameter to fall. There is no guarantee that a given confidence interval does capture the parameter, but there is a predictable probability of success. So the level of confidence represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. Okay, so imagine that you do a whole bunch of different samples, and then the level of confidence is representing the expected proportion of all of those intervals that do actually capture the parameter. The level of confidence is denoted as 1 minus alpha times 100%, where alpha is the significance level. So we'll write down a lot of information as soon as we look at one of the problems. So we want to make sure that we get all of our notation written down and know what the problem is asking us to do. Confidence intervals are typically written in the form, and it's an interval. So imagine like a number line going from left to right. You have your point estimate minus the margin of error for the left-hand side value, comma, you do the same point estimate plus the same margin of error for the right-hand side estimate. Okay, where the margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. Okay, the margin of error denoted by capital E, and our textbook, and sometimes it's also called the error bound for a population mean, and our textbook uses EBM for the margin of error. It depends on the confidence level, and we'll abbreviate that as CL for the confidence level. And so the confidence level is often considered the probability that the calculated confidence interval estimate will contain the true population parameter. However, it's more accurate to state that the confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken. Most often, it is the choice of the person constructing the confidence interval to choose a confidence level of 90% or higher, because the person wants to be reasonably certain of his or her conclusions. So 90% is common, 95% to 99%. Okay, you want it to be pretty high. Okay, so let's just get used to the construction of that confidence interval. Let's suppose that a sample mean is X bar is 22 and the margin of error is calculated already as E equals 3.4 with a 95% level of confidence. Let's find the confidence interval for the true mean and interpret its meaning. Okay, so no major calculations here. We're just going to kind of ease into it so we can actually think about what's going on here. So we're trying to find an estimate, a range of values that are somewhat reasonable for the population mean. So with our sample mean of X bar, I'll go ahead and write down what we want for the confidence interval. The confidence interval is going to be X bar minus the margin of error, comma, that same X bar and plus the margin of error. Okay, and so for this one, the margin of error is already calculated for us. And so we would just plug these pieces in and we would just say, okay, it's going to be 22 minus the 3.4, and then 22 plus the 3.4. And so if I calculate this out just real quick in the calculator, I got 18.6 on the low end. And then 22 plus 3.4, we get 25.4 on the high end. So that is our confidence interval for the true mean. Okay, so what we're thinking now is with a 95% level of confidence, we're 95% confidence that the true value of the population mean is somewhere between 18.6 and 25.4. Okay, we got that sample mean of 22. Okay, and so with this margin of error that we've calculated, we're expecting that this interval right here from 18.6 to 25.4, it's like a 95% chance that the population mean would be in there. But then more accurate, and that's the way we're going to write it down. So I'll write that down in a sentence in just a second. But technically, it's more accurate to say that the confidence level is the percent of confidence intervals that contain the true population parameter if we were going to do this a repeated number of times. Okay, but anyways, I'm going to write this down as a sentence for what this actually means with this 95% level of confidence. So I'm going to write it like this. We are 95% confident that the true value of the population mean is between 18.6 and 25.4. Okay, so that's the way that we can write this. Okay, so that's one way of interpreting it. Okay, so 95% confidence that the true value of the population mean is between that lower end and that upper end. Okay, so kind of a lot of information there. I think I'll go ahead and make a separate video for picking up on actually setting up the process here.